Hello friends, in today's class we are going to see about coprocessor and memory management mechanism. First let us see about the coprocessor. A coprocessor is a substitute for the CPU. So it is a similar processor, similar kind of CPU which is attached to the processor. So firstly, the Intel has introduced the floating point arithmetic as the first coprocessor unit. So this coprocessor dedicated for floating point arithmetic. So it will perform only the floating point arithmetic functions. So to support the coprocessor, some opcodes in the instruction to be is to reserve. We have to reserve some opcodes in the instruction. So the coprocessor instruction can load the or store the instruction within its register or outside of the register. So whenever the coprocessor is executing the instruction, the CPU has to wait till the coprocessor has to complete the task. Otherwise, the CPU can continue the executing at some other instruction while waiting for the coprocessor to finish. So here, whenever the CPU receives the coprocessor instruction, but the coprocessor is not attached with the device, then the trap is very helpful. So the trap will fetch the coprocessor instruction and it is able to execute in the software mode on the main CPU. Obviously it will delay the process of executing instruction of floating point instruction, but definitely it is very compatible option. So the ARM architecture can support up to 16 coprocessor. The coprocessor are able to perform load and store operation on their own register, or it can process the instruction in between the actual CPU register or memory to coprocessor register. Any operation or load store operation it can perform within a device. So an example ARM coprocessor is the floating point unit. This unit occupies two coprocessor units in the ARM architecture, number 1 and 2. But it appeared as a single unit to the programmer. So it provides 8 80-bit floating point data register, floating point status register, and the optional floating point status register. Next one is memory system mechanism. A normal model microprocessor do more than just read and write. So this feature improves the both speed and capacity of the memory system. So normally to improve the memory mechanism performance, we are adding caches to the memory system. Here this diagram represents the cache in the memory system. So here the cache is placed in between a main memory and cache controller. So the cache controller can able to access a cache and main memory. So whenever the CPU requesting for data, the cache controller sends the request to cache as well as the main memory. So whenever it finds the data in the cache, it represents the hit rate of the cache, which means the data is found inside the cache. So whenever there is no data in the cache controller has to wait till the main memory return the data which requested from the CPU. That is cache miss. Miss means missing of data inside the cache. So here this represents the cache types of misses inside the cache. That is the compulsory miss. This occurs at the first time the location is used. Then the capacity miss. Whenever there is two larger working set, there is a possibility of capacity miss. Then the conflict miss happens when the two location map to the same location in the cache. Then we can compute the average memory access time as a T average equal to hit into T cache, time taken to access the cache. Hit means the data we have find inside the cache, plus miss. Miss means what? The hit is not happening. So it is 1 minus hit. So that it means the data is available inside the memory. So the time taken to access the main memory. So that is the average time to access the memory. Means the data should be inside the main memory. So 1 minus hit 1 minus hit 2 into the main memory. Here there is a cache. There are two ways to associating cache. One is the direct mapped cache. Another one is set associative cache. In this direct mapped cache, we have the cache which is divided by the cache blocks. So each cache block has the block of valid, tag as well as the cache block. Here the data field represents the data inside the cache block, which is requested by the CPU. Then tag represents the index number of each cache block. Then the valid flag indicates whether the data inside the cache block is valid or not. So each address field consists of tag, index and offset. Here the index represents in order to find which cache block it has to access, and the tag is compared with the tag in the cache block. If both the tag is matched, means the data requested by the CPU is find inside the cache block, so that it means hit. So if this tag is matched with this tag, means it represents the hit. So whenever the length of the data field is too high and the LSB bit of your address is representing the offset, which is used to fetch the data field inside the cache block. So this is about the direct cache. Then the set associative cache. In the set associative cache, there is a disadvantage. It is very fast and relatively low, but it does have some limits in its caching power due to its simple scheme of mapping the cache onto the main memory. For example, consider the direct map cache with 4 blocks with the location of 0, 1, 2, 3. So all map to different blocks, but the location 4, 8, 12 all map to same block as a location 0, because this location is not available. Only the cache consists of 4 location, that is 0, 1, 2, 3. So apart from this location, if any other location coming, means the data is written onto the same memory block. So this is the main drawback of this cache. That's why we are going for set associative cache. In the set associative cache, it is characterized by the number of banks or way it uses. So giving an n-way set associative cache. A set is formed by all the blocks that are share the same index number. So in the case of direct map cache, the index number is not same. Here they are representing all the banks with the same index number. So each set is implemented with the direct map cache. A cache request is broadcast to all the banks simultaneously. If any of the set has the location, the cache reports the hit, although the memory location map onto the block using the same function. There are n separate blocks for each set of location. Therefore, we can simultaneously cache several locations that happen to the map onto the same cache block. The set associative cache structure incurs a little extra overhead and it is slightly slower than the direct map cache. But the higher hit rate is possible in the set associative cache. Thank you.